Algebra 2 Pre-Calc. We're doing the second video in 3.5, which is linear programming. Remember, this is kind of tedious and generally frustrating, and it's not something that you would do by hand, but we're going to walk through it so that you know how to recognize it and how it would work. There are computer programs that optimize things so that you don't have to. But if you're a coder, you might be the person who has to write the program that does this. So you need to know how it works to be the person that writes the program, even if you're not going to do it by hand later. So in linear programming, the maximum and minimum values of an objective function occur at one of the vertices of the feasible region, meaning that we have these four corners, right? So we have 20, 30, we have 20, 100, we have 80, 40, and we have 80, 30, right? One of these four is going to yield the largest possible revenue, right? And we know that we want to have a revenue in terms of x, y, which is what we wrote in example 1, right? So if we plug in the x's and y's into our revenue, what we're going to find is that we're able to figure out which one of these four is maximum. Now, I do want to point out that there's some logical issues here. This maximum can't possibly happen if you're not using everything you have. So the maximum won't happen with the lower x's and y's. Here's what I mean by that. If you recall example 1, he was able to plant up to 120 acres, right? So up to 120 acres. There's no way he makes as much money as he can if he's not planting the full 120, which means that neither the A corner or the D corner makes any sense. It's going to be one of these two that's the maximum. I only say that because logically it feels like a waste of time to plug in all four corners. Similarly, you can probably guess that this would be the corner that would be the minimum because he's only planting 50 acres. The guy's barely making enough to like feed his family. So anyway, so we're going to go ahead and walk through some of this. I will use some of the textbook graphs and stuff, and we're probably not going to do a P2 on your P1 just because it saves everyone's sanity if we're not typing and entering a million things forever. So let's go ahead and look at E2. So using the information in example 1, we're going to maximize the objective function. Now, a reminder, our objective function, right, our r of x, y, was, we did 3.15 times 113.5. And again, if you wanted to clean that up, you could, x, plus, I think it was a 4.45 times a 3.58. I'm double checking, yep, 35.8. Sometimes I put the decimal in the wrong spot, y. Okay, so that's our objective function, and we want to maximize that function, right? So what we're going to do is we're going to plug in the different corners that we have, right? So the corners that we had were 20, 30, right? If we flash back for a sec, 20, 100, 20, 100, 80, 40, and 80, 30. So 80, 40, and 80, 30, right? So we're gonna plug in that x, y into all those values. Now, they're going to suggest that you do this in a table, and in a second I'm going to pull down this giant gray blocking thing, and we're going to see that. Keep in mind, you can't put this in y equals in your calculator because it's not y equals. You didn't solve this for y. But what you can do, right, is you can quit out of this, right, and you could type in 20, oh, sorry, I take the 20 back. Type in 3.15 times my 113.5, in parentheses I'm going to put the 20, right, plus 4.45 times the 35.8, and then in parentheses I'm going to put 30. Now, we've already established when I talked about the last one that we know 2030 is not going to be the max, but I could type it in like this, right? Here's the cool thing your calculator can do. If you want to find the next one, right, so I just found the value for 20, 30, and I'll write it down over here. Let me just move this off to the side so that I can actually still see it while I write. Okay, so this ended up yielding a 11929.8. Right, that's how much money he made, which sounds like a lot of money until you realize like that's his whole income, and maybe it's a pretty big farm, so that's not great. Okay, if I want to do the next one, I don't know if you know this trick, but if you don't, hopefully you will after this. I'm going to hit second enter. I'm not going to retype that entire mess, and I notice I want to keep the x as 20, but I want to change the y to 100. So where there's a 30. I'm going to do 1, 0, 0 and close the parentheses, right? And I hit enter. So now I get this 23,000. Well, that's definitely better, right? That's significantly more money. So I'm going to get this 230.081.5. And there are zeros at the end of that because it's money, but I'm just lazy. Okay, cool. And then if I want to do the next one, right, I can hit second enter. That recalls the last thing I typed. And then now I want to change the 20 to a 40, right? To an 80. My x is an 80, so 80. And I want to change the 100 to a 40, which will be 40 and then delete. If you ever need to insert something and you so let's say you needed to make the x 3 digits, which would be much harder, you can do second insert and then it'll let you insert a value, just so you're aware. Okay, so now I hit enter. Oh, that one's definitely way more money. So right, so 80 comma 40 right now is much better. So this is a 34974.40. That's a lot more money, right? And then we already know the last one's not going to be the biggest if I hit second enter, because as I mentioned before, if you're not using every acre of land you have, it can't possibly be the best possible situation. And sure enough, that's less money. So so I end up with this being a 33381.30. Okay, so now what I'm going to do, now that you've seen how we did that in the calculator, right, I'm going to go ahead and show you that that's really all that this did. Okay, so, and sure enough, you'll find that C is the one that maximizes our money, right? So C is the one that's the best option. But again, I'm going to point out that pretty much, and they do give you another way to do this. They point out that if you wanted to solve this objective function for Y, you could actually spot that that's where it has its largest value. So anyway, so thus Mr. Desmond should plant 80 acres of corn and 40 acres of wheat, and that's the deal. Now, I'm not going to make you go back to P1 and do the same thing, make the same table with all the stuff for these corn and soybeans, because that seems kind of silly, and this is a little bit tedious and drawn out. So we're going to keep moving forward, and we're going to do some other examples, and then that'll pretty much be it for us in linear programming. All right, so we're going to find the max and minimum values, if they exist, of this objective, of this set of constraints for this objective function for s equals 2x plus 3y. So we could graph this by hand, right, and that's just fine, but I figured we're going to have to do that in P3 anyway, so I'm going to walk you through this. So the first thing we're going to do is graph the function, right? So let's graph the function, right? So we're going to graph, oh, my bad, taking it back. All right, so there we go. So we graph the function. What you're going to find is that this is an unbounded region, right? So you're going to graph the function, right? You're going to graph each one of these constraints, and you're going to get this window. So then you're going to need to find each spot where these points intersect, right? So when we go to find these values, right, in order to do this, we're basically going to have to find where x equals 0 intersects this 5x plus y equals 20, right? So if we wanted to solve this, right, if we plugged in x is 0, we'd get y is 20. So that's the point 0, comma 20. That's the first, so this point A, right, so my corners, right, so my corners are A is 0, comma 20, right? To find the next corner, well, B happens when this curve runs into this curve. So you're going to have to solve 5x plus y equals 20 and x plus y equals 12. So how you choose to solve that is up to you. We do know systems of equations, and they just tell you in this example that it's solved, and that's nice of them, but in the real world, you'd probably have to figure out how to solve it. The way I would solve it is by multiplying this equation by a -1, right? And what would happen is I could then add straight down and get 4x equals 8. So I know x is 2. Once I know x is 2, I know that x plus y is 12, so y must be 10. So point B was 2, comma 10. And again, your book just kind of says, oh, hey, here are the answers, and that's how you get there. To get point C, I would need to know where the x plus y equals 12 runs into the x plus 2y is 16. So to do that, I'm going to go ahead and find where these two run into each other. I'll go ahead and keep this thing multiplied by -1, so I'll have a negative x and a negative y is a negative 12, and I want x plus 2y is 16. So when I add straight down, I get y equals 4, right? Once I know y is 4, I know that x plus y was 12, so x must be 8. So point C is the point 8, comma 4, right? And then point D is the point where y equals 0. So in point D, I know that D is the point where y is 0 and x plus 2y is 16. So x plus 0 is 16, so x must be 16. And I can also see that by visual inspection. So those are my 4 corners, right? So I found the 4 corners. Once I find the 4 corners, I need to plug them into this objective function, but I was already given that objective function, right? So I don't have to like write the objective function here. So if we delete this guy now, here's my objective function, s equals 2x plus 3y. So I plug in all of those corners, and I find that the maximum happens at 60, right? So that's A, right? And the minimum happens at the 28, right? So I'm sorry, I lied. There is no maximum. I take that back. Wasn't even noticing the feasible region. So let's go back for a second and talk about why there is no max. There is no maximum value because this goes on and gets bigger forever. So there's no max. So here's the minimum, because this is bounded on the bottom half. That's the min. But there's no max because the x goes to infinity and the y's also go to infinity, right? They're not bounded in this direction, right? So no max, and the min is a 28, okay? At 8, 4. Cool. Let's walk through another example. So you're going to try the same thing with P3. So in P3, you're going to go ahead and figure out the max and min values. Now, I'm going to point out that you could probably get away with not graphing this. I'm going to suggest it's smarter to graph it, right? So I'm going to graph it, but if you chose not to, you could probably get away with not graphing it. So here's x is 3, and here's x is 8, 4, 5, 6, 7, 8, right? I know that I'm shading in between those two, so these are big fat no's on either side, right? I know that y is between 2 and 6, so here's 2, so not shading below that, and 6, so 3, 4, 5, 6. So I'm not shading above this, right? So these were also, remember that had to shade between the green lines, so over here and over here also knows. So this square is the only possible region at the moment. Okay, and then if I graph this guy, right, this is y is greater than or equal to a negative 2x plus 12. So 2, 4, 6, 8, 10, there's 12. Right, down to right 1, 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 down to right 1. All right, and I want to shade above, right, because it says y is greater than or equal to, so it's solid and above, which means that this spot's a no. So my feasible region ends up being right here. Now, some of these corners are super duper duper predictable, right? Wherever the green meets the red, the corners should be pretty predictable. So there's a couple corners. There's this guy, call him A. Here's B. Here's C. So A, B, and C are all where green stuff meets red stuff, so they should be pretty predictable. Sorry, that's D. And then this guy right here is E, right? The reason green and red are predictable is that we're given the x and y values already, right? So this spot, A, is where x is 3 and y is 6, right? So A is 3, 6, right? B is where x is 8 and y is 6, right? C is where x is 8 and y is 2. Now, but when we get to D and E, now we're going to actually have to pay attention, right? So D is where y is definitely 2, right? That's still on the line where y is 2, just like E is definitely where x is a 3. But for both of these guys lie on the line where 2x plus y is 12, right? So if I plug in sorry guys, my headphone got removed for a sec. So if I plug in, let's go ahead for this one and plug in where x is 3, right? That's going to be 6 plus y is 12, so y must be 6. And you can see that by visual inspection too. You could physically just count, right? In theory, oh, that's because that's supposed to adhere and I just missed. Never mind, there is no E. We already have 3, 6. It just missed. This is right here. I just missed the dot. Okay, sorry, there is no E. It's A. My bad. And then for D, right, we're plugging in 2 for y, so that's going to be 2x equals 10, so my x is 5. And again, you could spot that by just counting. So those are my corners, right? And you can see here, that's that whole E confusion. That's why I'm saying that graphing by hand is the worst. All right, so Now, if we go ahead and plug all of those into my objective function, which is this c equals 3x plus 4, right? So we're going to go ahead and look at our 4 corners of the feasible region, right? So I'm going to go ahead and plug each one of those in, and we're going to see where there's a max and a min. Oh, sorry, as a side note, and I shouldn't have erased it, you'll notice that this is a bounded region, right? This is bounded, so it will have a max and a min at a corner, right? So it will have a max and a min at a corner because it is a bounded region. So if we erase that, some of the space now, that was 5 comma 2, my bad. Okay, so if we clean this up, right, 5 comma 2. Okay, so now when I go to plug in, right, so 3x plus 4y, right, that's what the c is equal to. So here, 3x is going to be a 9, and 4y is going to be a 24, so that's a 33, right? Here I'm going to get 24 plus 24, which should be 48. Right here I'm going to get 24 plus 8, which should be 32. And here I'm going to get 15 plus 8, which is a 23. So the max is the 48 at 8 comma 6. Because again, this is bounded, so there is a max and the min. And the min is the 23 at 5 comma 2. Right, and that makes somewhat intuitive sense, right? You could guess that either A or B is going to be the minimum value just by looking, the fact that they're the smaller values closer to the origin, and that B is going to be the largest because it's the one farthest from the origin. So there you have it. All right, cool. And that's our video on linear programming.